All right, so let's talk about some specific sampling techniques. So these are considered to be bad techniques. All right, these are techniques that often will result in bias, so we want to try to avoid. Convenience sample. So this is just asking people that are easy to reach, convenience sample. If I want to take a survey of kids at our school and I just ask the kids that were in my class, that's just doing what's convenient. If you wanted to get the opinions of high school kids and you just asked your friends, that's just what's convenient. And obviously, I hope you guys can see the problem with that. Just because they're your friends doesn't mean they represent the opinions of the entire school, right? Just because you're an AP stat doesn't mean that you're, sometimes it's not so bad. Sometimes you can get results that are decent, but usually no. Voluntary response sample. So obviously if you do a voluntary response sample, if people are just choosing whether they're in the sample or not, then you're going to get voluntary response bias. These are used in a lot of studies. You just got to be careful. Read the literature and figure out how the samples were taken. All right, identify the sampling method used and discuss possible sources of bias. So this is going to be the quick part. I'm not going to do the whole bias explanation. Remember what we did here? Part 1, why was there bias? Part 2, does the bias result in an over or under estimate for our statistics? I'm not going to do that for each of these. I want to be quicker about it. Former Fox commentator Lou Dobbs has strong feelings against illegal immigration. One of his shows was largely devoted to attacking a proposal to offer driver's license to illegal aliens. During his show, he invited viewers to go online to vote on the question, would you be less likely to vote for a presidential candidate who supports giving driver's license to illegal aliens? 97% of the 7,000 people who surveyed by the end of the show said yes. So this is what people love to report. 97% of 7,000 people. If the sample is big, then how could it possibly be wrong, right? So this was a voluntary response sample. And I don't know, I hope you can see the bias, the problem with it. So Lou Dobbs works at Fox News. Fox News is pretty conservative. Conservatives are usually a little bit more about strong border control. Or who cares about Fox News and conservatives? I shouldn't even mention that. I'm sorry. But this guy has strong feelings against legal immigration. So the types of people that probably watch his show are people that agree with him. Not very often do we watch shows of people that we dislike or disagree with. So obviously, the people that watch his show are probably not representative of all the people in the country, right? AP Stats teacher was curious about the average GPA of students at his school, so he used the 32 students in his class as a sample and concluded that the average GPA was about 3.85. So this is a convenience sample. Gosh, I'm terrible at spelling. Convenience sample. And again, if you're in AP Stats, does that, that's an AP class. It's advanced placement. Some students don't take any advanced placement classes. There's nothing that really indicates that the types of students that take AP Stats would be representative, on average, as all the other kids at the school. Principal of a school is wondering what percentage of the student body has cheated on a test in the last month. He brings every student in the high school into his room individually and asks them, have you cheated on a test in the last 30 days? He was pleased to find that only 1% of the student body had cheated in the last month. You probably would be amazed if it was actually 1%. I'm pretty sure that the report would be 0%. What's the sampling technique? And if we were in class, I'd let you chew on this one a little bit. Maybe pause the video and see if you can get it on your own. If he surveyed every student, then there was no sample taken. He performed a census. he asked everybody of interest, then he performed a census. So if it's a census, then the results must be 100% correct because he asked everybody. Well, the census means that there's no sampling problem. There's no sampling bias. But we have major problem with response bias. When you bring kids into the room and the principal asks you, have you ever cheated on a test? If a kid had cheated on a test, they would probably be socially pressured into, saying no, they hadn't, right? So these results are worthless. So how do we sample well? Well, first we got our random sampling. Just random sampling. This is kind of a general term. This is general. A random sample is any sampling technique that uses a chance process. So instead of you just picking those words in the Federalist Papers, we use a calculator to randomly generate numbers. So some kind of chance process. Putting numbers into a hat. Flipping a coin. Rolling a die. Something like that. So as long as a sampling technique uses a chance process, we call it a random sample. There's a special, we've got to put a bunch of stars on this one, guys. This is a big one. A simple random sample, we call it an SRS. A simple random sample is a very specific sampling technique. Okay? It is a random sample because it's going to use a chance process, but it's going to go beyond that. A simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equally likely chance of being selected in the sample. Okay? Every group of size n has an equally likely chance to be selected for the sample. Please don't confuse that with every individual has an equally likely chance of being selected for the sample. By the way, in an SRS, every individual does have an equally likely chance of being selected. But there are many sampling techniques where every individual has an equally likely chance of being selected, but every possible sample of size n is not equally likely. So we're going to have to spend a little bit of time on this to try to make sure that this is solidified in our minds. So an SRS gives every possible sample of the desired size an equally likely chance of being selected, and gives each member of the population an equally likely chance of being selected. Okay. Most of the statistical analysis that we're going to do later this year are going to require an SRS. Okay, an SRS is kind of the standard, the gold standard for sampling techniques, and it's going to be the foundation of all of our analysis in the second semester. So a simple random sample can be thought of as a completely random technique. No grouping of people, simply number the people and randomly select the numbers. Our Federalist paper technique was actually a SRS. Because why? That's a good there. We can finally talk about why this. So first of all, if we if we randomly select 5 numbers, then does every word have an equal likely chance of being selected? Yes. Every word has an equal likely chance of being selected. Is that what makes it an SRS? No. What makes it an SRS is every sample of size 5 has an equally likely chance of being selected. For example, these 5 words that I selected, those 5 words had the same chance of being selected as these 5 words. Every combination of 5 words has an equally likely chance of being selected. That's what makes it an SRS. So please try to understand this, guys, and try to get this right on the test. A common question is, this technique says every individual has an equally likely chance of being selected. Is it an SRS? Not necessarily. Every sample of size 5 must have an equal likely chance of being selected. Okay? But if you just number them and draw them, that's going to be an SRS. All right. So the technique we use to get, so there's a couple different ways to get an SRS. We can use a random number table. We could use our calculator, or we could put names into a hat. So this is kind of a common, it's becoming less common, but it's kind of a common AP question. How would you get an SRS? Describe in detail how you would select the sample. So let's do an example, and here's the 3 methods that you could use. You don't have to do all 3, you can just pick one. So we got a random number table which just basically has random digits from 0 to 9 in each of its spots. So how do we take an SRS? Describe how to take an SRS of 20 students from the 450 kids in the upper school at the John Cooper School. So our population size is 450, and I want to take a sample of size 20. So to use a random number table, we would number every student from 001 to 450. We'll take a list of all the students and number them. Take 3 digits from the table. So my first one is going to be 111. If the number is between 001 and 450, for example 11 is, then we're going to select that student. So we take student 111 for our sample. There's the first kid. If the number is from 451 to 999, we'll just have to skip it. So the next number would be 643. So 643 we would skip. The next number would be 631. 631 we would skip. Next number is 875. 875 we would skip. The next number is 061. 061 we would take that student. That's our second student. And then you just keep going. 376, take them. 742, skip it. 632, skip it. 75, take them. Okay? And we're going to do that until we get 20 kids. Also, if the 3-digit number is a repeat from a previously used number, then you also have to skip it. So if I got another 111, I would have to skip it. Okay? Continue selecting 3-digit numbers in this way until we have selected 20 students without repeats. Okay? This is your sample. So this is how you're going to answer that question. Okay? That's how you would use the random number table. Calculator. This is my preferred method. My preferred method for doing things. This is my preferred method for explaining this, for answering this question. This one here is just sad face. I don't like doing this, nor do I like writing it down for a response. So how do we use our calculator? Number every student from 001 to 450. Use randint 1 to 450 on the calculator to select a random integer between 1 and 450. If the student associated with that, select the student associated with that number for the sample. So if we want to do this on our calculator, I'd do randint 1 to 450. So I'm going to select kid 91. I'm going to select kid 360. I'm going to select kid 429. I'm going to keep doing this. This is kind of nice because I don't get those extras. I don't get those 600s that I need to throw out. But I still could get a repeat. Okay? Doesn't look like I got any repeats yet, but we're selecting 20, and you can get repeats here. Okay? So, if the 3-digit number is a repeat from a previous used number, skip it and continue. Continue selecting 3-digit numbers until we have 20 students without repeats. This is your sample. And then the last technique is slips in a hat, and this is fine to answer on these tests as well. Write every student's name on an equally sized slip of paper and fold them all consistently. You don't want one to be super small and another one to be huge, right? Because then you're going to be more likely to pick the big one. Place all the slips of paper into a box or a hat. Mix the slips thoroughly. Draw out 20 slips one at a time without replacement. Select those students for your sample. You just need to have detail here. Like, you need to comment on repeats. You need to say that you're going to mix. I saw a question where they marked it off if you didn't explicitly say that you need to mix the slips of papers in the hat. You went from a 4 to a 3 if you didn't say that you're going to mix the papers in a hat. How insane is that? Whatever. When asked to describe how to select a sample, you must provide enough detail that a sensible person would be able to follow your instructions exactly, and everyone that read your instructions would do the exact same thing. You cannot assume that this person will fill in the blanks with their knowledge. Like, oh yeah, of course, mix it up. Of course, take out the repeats. Of course, don't count the numbers that are not. No, no, no. No, of course, anything. You have to have enough detail to say exactly what the procedure is. Okay?